Hello everyone, this is Samir from Audio Science Review. I have another review for you, and that is a USB cable by Nordost. I don't know how to pronounce the actual model number, Tyr 2 or TYR2. It's an odd sounding name, sounds like a car tire or something. But you're not here to hear my commentary on naming, so let's move on. The cable, as I mentioned, is a USB cable. Here's the real thing. I was actually quite surprised of, oops, sorry, hit the microphone. I was surprised of how ordinary it looks. Usually these cables, expensive cables, are dressed quite nice. And this one is not, despite costing $1,400 for 1 meter cable. So this is the whole thing. And is 1,400. Some of you may think that's an outrageous amount of money, but USB cables just this length go up to $20,000 or more. So for a high-end cable buyer, this is actually a budget one, if you will. For someone like me, a budget cable is this Amazon Basics, which I use for everything, and it costs less than $7. Including shipping from Amazon. It's quite flexible and easy to use. It's longer than this one. This one, as you can tell, is quite stiff. You may say, well, it don't matter, but if you try to twist this thing, which you have to align this kind of USB connector, it's pain in the neck. I mean, literally, you have to put a ton of force on it to try to bend it. I think that's due to the use of using solid wire in here, which is a mistake. I mean, something that needs to flex. You don't use solid wire, but that's what they're doing. But this one, of course, is stranded. It's got this great feel. Almost feels like silicone wire, although I'm pretty sure it isn't, because that would be more expensive. But regardless of what it is, it's quite flexible, and it's 2 meter length, unlike that one that's 1 meter length. I think one of the resellers is Music Direct, and it had this tagline in there: dramatically raise computer audio performance with one move. Reference grade Nordost Tyr 2 USB cable. Enhances sound staging, imaging, dynamics, detail, and precision. Of course, there's no backup for any of those, but if it does even 1 out of 5 of these things, that would be a great thing. So let's get into some objective measurements so that it's repeatable data and reliable data. One thing is a pedantic comment to make, but I want to make sure you all are careful as you read the advertising for these cables. None of us listen to a USB cable. The USB cable is carrying digital data, and that data then goes to a DAC that is then converting that much later to analog waveforms we listen to. So ultimately, the only thing that matters is the sound waves coming out of my audio equipment. I don't care what kind of screw they use to mount things together or whatever. What matters is that what is the sound like at the end of the day. And to do that, I grabbed this Topping DX3 Pro Plus. It's a very high performance headphone amp and DAC, but only costs $200 for the whole package, so it's probably equivalent to a sales tax on this cable and shipping. But anyway, it's a very high performance, very, very resolving DAC, and I just had pulled it out for another testing. Nothing special about it. I just have probably 100 different DACs in the back, and I just grabbed this one for some other testing, and then I just reused it for this. Normally for testing, I use this Shet Modi 2 DAC. This is one of the few and rarest DACs I've found that actually cares about quality of the USB power and USB signal, in that if your computer's noisy, this thing puts out noisy stuff. If your 5-volt supply is not clean, this thing degrades. And so it turns out to be revealing of differences in USB cables, and indeed I've done a test like that in the past. And the winner there, by the way, was the shortest cable wins on this thing. Anyway, I try to use it for this, and whatever's changed in my system or whatever, this thing now was just jumping up and down in performance, and it would not lock to any meaningful data. Its sign out would change from 85 to 90. So I couldn't take one measurement, change cables, and I could take another the measurement because then things were changing so much. So if you've seen me use this in the past and want to know why I didn't use a DAC that's sensitive to that, is this. Of course, no good DAC design will have sensitivity to USB cables or USB source or computer activity for that matter. But anyway, going back to DX3 Pro, using my standard Amazon Basics 6-foot cable, 2-meter cable, we see that it has a SINAD of 115 dB. That means if you sum the noise and the distortion and compare it to the signal that I gave it, which is this tall, oops, you can't see my cursor. This tall signal is what we wanted, what we told the DAC to produce, and it produced this other stuff and some amount of noise. If you take all that noise and all of those spikes together and compare them to this, they're 115 decibels lower. Threshold of hearing is 115 decibels negative from reference. So that tells me that this DAC is completely transparent to as far as this noise and distortions. You can't hear either one of them. If you play at the reference level of about 115 dB to 120 dB, which is quite loud. But again, this is with Amazon Basics cable. So nothing special was needed to get this level of performance. Now let's change the cable to Nordost and see what happens. Well, nothing happens. Look at even SINAD is still 115. Don't worry about the fractional differences every run. This thing is, if you look at it real time, it's changing all the time. But essentially it's 115 now, and it was 115 before. But even beyond that, look at the output that it puts out, 2.170 volts, 2.170 volts. So there's just no loudness difference at all. The sine waves coming out identically. Again, these things also vary a little bit from run to run. Look at the frequency accuracy, 1.00005 zeros worth of accuracy as far as timing. Same with my previous test, 5 zeros in there as far as timing. So as far as we can tell, loudness hasn't changed, distortion hasn't changed, noise hasn't changed, timing accuracy hasn't changed. Not a thing, even a hair out of place with switching USB cables. So we could stop here and say, yeah, I mean, the waveform coming out of this thing is so accurate. But people complain, well, you use just one tone. What if you use other tones and music is not one tone? Okay, I have a test called a multitone that has 32 tones in it mixed up in a specific ratio I won't get into. And I run this test at 192 kilohertz sampling rate, so much higher than the previous one, which was the CD rate. And the bandwidth, therefore, is half of sampling rate always. So we have 96 kilohertz of bandwidth. So we're actually including a lot of ultrasonic noise and distortion. And then I run the test with Amazon Basics versus Nordost. And look at these two graphs. They're just landing on top of each other. The red is Nordost and Amazon Basics in blue. The graph actually looks purple because the two mix together. There's a tiny little hair differences here and there, but that's just like run-to-run variations. But, if you look at it, the top is 0, the bottom is as low as minus 160 dB. The depth that we go to measure is just so far beyond our hearing threshold. That's just amazing. And even when we do that, we still don't see any difference whatsoever. But we can zoom in, just look at the noise. Here I have everything hooked up just the way I made the previous measurements, except that I haven't told the computer to generate any signal. So everything's connected, USB cables connected, outputs connected. So we're just looking at the noise and distortion that's coming out of the DAC. And if we do that, we see that there's just no difference again between the two. Again, you could squint and say maybe there's a hair difference in here, but that's just run-to-run variations. This is just inherent noise that's inside the DAC, inside the computer, wherever it's bleeding on this thing. So it really, there's nothing different about the two codecs. And the key thing is also to notice is the bandwidth of measurements. I have gone to 1 megahertz sampling on Audio Precision, which gives you 500 kilohertz of bandwidth. And so we're going way past audible band. Audio band ends over here, but we've gone way past for people who think there's EMI, RFI differences in this and that. Well, I've gone 25 times past hearing range. There's still nothing. Look at the shape of the noise floor. It's the same between red and the blue, and the same spikes exist everywhere. Look at this garbage at the end over here. That's also, in both of them. So, it just, there's nothing there. But again, look at how low we're going on as far as measurement accuracy. We can do the same test this time with a wide bandwidth. So going back to that 1 kilohertz tone, instead of just looking at it up to 20 kilohertz, we can go all the way up to 90 kilohertz spectrum. And again, we see nothing different in here. The two DACs have the two cables demonstrate the same output out of the DAC, which is all that we care about. Now, people don't know any better, always come back and says, well, those were all frequency tests, and how about timing? Well, I won't go into it right now. I think I have another video on timing. But I say, all right, you want to see timing tests? I'll show you the mother of all timing tests. This DAC can go very high sample rate of 768 kilohertz. So I set the topping to 768 kilohertz sampling. So we're pushing the data rate on USB now to far higher rate than 44. So this is, 25 times more or whatever it is. So the USB cable is being much more busy right now, sending 24-bit data at 768,000 times per channel per second. And then I sent a square wave to the DAC, and here's the analog output. We see that it's almost perfect. It can never be perfect because the bandwidth that's required for a perfect square wave is infinite. We obviously don't have infinite because the sampling rate is way below infinite. But the key thing is that there's no difference between these two cables. You might say, well, this graph is low resolution. What if you zoomed in on the transition? Okay, here's a zoomed in on the transition. And you can see that all these little artifacts are because of the bandwidth limiting. And it's the same in both. It's just the cable is not able to influence anything whatsoever, even though I'm going, microsecond resolution now in timing here, zooming in just this little transition. And there's just absolutely no difference. Now, one test I usually do is I take a transformer, AC transformer, and I wiggle it around the cable to see how much 60 hertz it picks up. Most analog cables are susceptible to that, and when I'm measuring RCA cables and what have you, that will induce 60 hertz, which shows up in these measurements. Here you can see there's just nothing here, and indeed that's what I found. Neither cable was sensitive to this form of magnetic interference from the transformer. Both the Amazon and the Nordost cable were just as good in that regard, which is nice. I got it close to the RCA cables coming out of this DAC, as it doesn't have balanced output, and immediately I saw 60 hertz go up. So the test is valid. This transformer is radiating magnetic interference, but it does nothing to USB cables in this setup. So another thing I do is, people always come back and say, well, I don't listen to graphs. I listen to music, and, why didn't you do a listening test? Okay, I do a listening test. So I hooked up the first Amazon Basics to it. I plugged in my Dan Clark Stealth, which is a $4,000 headphone. It's state-of-the-art, the best headphone I've ever tested, and has exceedingly low distortion. The level of distortion in this rivals electronic devices. It's that good. It also blocks outside noise, so you can hear really deep into your recording. I listened with Amazon Basics first. I have this collection of reference tracks, which you can find on Audio Science Review. And it just sounded gorgeous and beautiful, and, you didn't want anything else. I switched then to the Nordost cable. Sorry, making noise. And immediately I thought the sound more congested and collapsed. You would think, I hear improvement. I didn't. Now, going back to measurements, you say, well, you weren't supposed to hear anything. How come you heard something? Well, to confirm that, I went back to the Amazon Basics cable, and it sounded better. It's like, wow, there's a difference. But I didn't stop there. I switched back to the Nordost cable. Now the Nordost cable sounded better. I went back to the Amazon one, and the Amazon sounded better. It always seemed to be the second one I listened to, except for the first iteration. It was fascinating that whatever I thought was better, which was sort of the music sounded a little louder and the highs were a little bit more clear, it would just fade out that effect over a few seconds. And so when I did the change again, it would sort of peak back up and fade out. So all of this is obviously a perception problem we have. The sound waves did not change in either case. It's just that my brain is operating differently. I'm focusing on what's different, and I hear things or listen to different part of the music that's playing in every iteration. And a proper test like this would have been blind, and then I could listen for 30 seconds, and then I'll listen to the other one for 30 seconds, or 30 days if you want. And I guarantee you, whatever I thought it was in one, I would also hear it in the other one, or vice versa. But people run sighted tests, and they claim to hear all the improvements. Here's my sighted test. And yes, I heard improvements. You're not crazy. You're not delusional. You're just human, so am I. I hear improvements that aren't there because the testing is improper. My brain and perception is different, and it's like a microscope that you focus and tune it, then you'll see more, but the object doesn't change in either case on this thing. And I tell a story about my wife coming up, and the right middle of this testing telling me that the sounds a lot, your stereo sounds better, and she asked the usual question, what'd you change? I told her, well, not this time, because there's no way you could have heard what I was listening to, because I had headphones on. And of course, she knew I caught her, and she was not going to be able to cash in that chip with me on anything else, and went downstairs to the kitchen disappointed. So we move along. So as you can see, I've done extensive testing in here. I've come to this thing from different angles, different tests, one frequency, multiple frequencies, high frequency, low frequencies, and it's just there's no difference. Why is there no difference? Well, when you buy a decent DAC and amp, what you're paying for is that kind of isolation and not caring about the USB vagaries. And even if it did have problems with USB, it would be at the source of the noise and junk inside your PC. What gets picked up by a cable is so minute, and the cables, these are such short cables that you're not remotely straining the protocol itself. If you had a 30-foot cable, yeah, there would be differences. One may work and one may not. By the way, when they don't work, and I've recorded and put those clips online, you hear static, you hear buzzing. It's very clear. It's never a case where a working cable all of a sudden has better sound stage, better depth or anything. It never does that. It's just that the broken cable will have buzzing and static and noise, and that comes and goes because the digital bits are falling on the floor. But until that, if you just pull back where the cable's working, then all of a sudden it's done its job on this thing. So hardly anyone strings an extremely long cable for their DACs. I know some people put a computer in a different room and then run a long USB cable. In that case, you just need a good USB cable, not an audiophile one. That frankly, there's no proof that this thing does any better. I mean, it's not like the company said, oh, here's a 30-foot version of ours, and look at the quality of the bits going across compared to an Amazon Basics one. Okay, then we'll go look at that. But you know how many people buy this cable versus that? And if this cable had problems, so millions of people would complain. And they don't. They use this for all manner of things, and they don't complain. And despite the fact that this cable was twice as long as that cable, and therefore more susceptible to losses and degradation, in reality, our DACs don't care. So in a typical environment where you have a source, streamer, server, whatever, driving a DAC for audio use, there's absolutely no problem in here. If you go buy a proper audio device, don't buy a Shed Modi 2 because of, well, it's an obsolete product. But at the time, it wasn't obsolete. A lot of people thought this was a good DAC till I go test it. And I'm like, wait a second. Depending on what port I plug it into, its performance changes. So it's just not good. This thing does have issues. So it's a lesson there, not buying stuff for which you don't have measurements, either proper manufacturer's measurements or mine. So please don't spend your money on cables like this. If you have the money, use it to buy more music. If music is what matters, and go do that. If your ears are the only thing that matters, okay, set up a blind test where you don't know which cable you're listening to. Get this Amazon Basic cable and repeat the test 10 times. See if you get 9 times out of 10 right which cable is which. Leave a video recorder running, or a camera, your phone, or whatever, so we have proof of what you did, and you could be very, very, very famous if you can prove any cable like this would make an improvement. Until then, the data is very, very conclusive. Engineering and science of what's going on is also very conclusive, and so don't waste your money on stuff like this. Okay, I appreciate the owner that sent this to me, and I'll see you in a future video. Bye-bye.